Hey everyone, and welcome. Today we're going to talk about something that is literally all around us, powering almost everything we do. We're diving into the three fundamental effects of electric current.
Okay, so to get us started, let me ask you something. What could a toaster, a giant junkyard crane that lifts cars, and a simple, shiny spoon possibly have in common? I mean, they seem totally unrelated, right? But they all share a very powerful secret.
And yeah, you guessed it, that secret is electric current. But here's the twist. It's not just about turning things on. Each of those objects is a perfect example of one of three totally different, almost magical effects that electricity can produce.
You see, when we talk about electricity, we're actually talking about its power to do three distinct things. It can create heat, it can create a magnetic field, and it can even cause chemical reactions. So, let's break down each of these secret powers one by one.
Okay, first up, let's dive into the most familiar effect, heat. This is the one we see and feel every single day, from the stove in our kitchen to the lights hanging over our heads. So here's the basic idea, and it's actually pretty simple. When electricity pushes its way through a material, it creates a kind of friction on a microscopic level. And what happens when you have friction? You get heat. This is precisely what makes the tiny wire inside a light bulb get so incredibly hot that it literally glows bright. So, with that in mind, let's say you want to build something that gets really hot on purpose, like an electric heater. What material would you use for that job? Would you pick A, copper, which we know is a great conductor, or would you pick B, nichrome? And the answer is nichrome, which might seem a little weird at first. See, copper is fantastic for wires because it lets electricity zip through easily without making much heat. But nichrome is special because it does the opposite. It resists that flow. All that electrical energy gets blocked, and it has to go somewhere, so it turns into intense heat. Perfect for those glowing red elements in your toaster. All right, so from the visible glow of heat, we're going to move on to our next effect, an invisible force that's powerful enough to lift mountains, well, mountains of metal anyway. Let's talk about magnetism. This is so cool. Every single time an electric current moves through a wire, it automatically creates a magnetic field around that wire. It's just a fundamental law of physics. It's invisible, but it's there. And when you take that wire and wrap it into a tight coil, you create something amazing, an electromagnet. Okay, so if you've got a basic electromagnet, how do you power it up? Do you make it stronger by using fewer coils of wire or by adding more? You increase the number of turns. A really good way to picture this is to think about a rope. One single strand is pretty weak, but if you coil hundreds of strands together, you get an incredibly strong rope. It's the exact same idea here. Each extra coil of wire adds its magnetic force to the pile, creating one big, powerful magnetic field. And this effect isn't just a fun science experiment. It's everywhere. Electromagnets are what make an old-school doorbell ring. They're what make the speakers in your phone or headphones work. They are the absolute heart of electric motors. And yep, they're what give those huge junkyard cranes the power to lift a car. All right, so we've covered heat and we've covered magnetism. But electricity has one more trick up its sleeve, and this is the one that might just surprise you the most. It can actually rearrange matter itself. Let's look at its chemical touch. So this effect happens when you pass an electric current through certain liquids instead of a solid wire. When you do this, the electricity can literally trigger chemical reactions, breaking molecules apart or causing new ones to form. But, and this is a big but, it only works if the liquid can actually conduct electricity. So to see what I mean, let's just look at conductivity. Here, if we stick a piece of coal into a simple circuit, nothing happens. The bulb stays off because coal breaks the circuit. But if we swap it out for a steel spoon, boom, the bulb lights right up. The spoon completes the circuit because metal is a great conductor. Now, it's not just about solids. Some liquids are great conductors, while others are pretty terrible. For instance, lemon juice and tap water both conduct electricity pretty well. That's because they have tiny charged particles in them that the current can use to travel. But things like vegetable oil or sugar water, they don't have those free-moving particles, so the electricity just hits a dead end. So how do we actually use this in the real world? Well, one of the biggest applications is called electroplating. What you're seeing here is a process where a current running through a special solution can actually dissolve copper from one piece of metal and deposit it as a perfect thin layer onto another object. It's like painting with metal atoms. And why does that matter? Well, electroplating is everywhere. It's how we coat iron with zinc to keep it from rusting. It's how we get that shiny, super durable chromium finish on our faucets and on bicycle bells. It's even used to put a tiny protective layer of tin inside food cans to keep our food safe. It's incredible.
So there you have it, the 3 effects. And they're not just separate ideas. They are the interconnected forces that have completely shaped the world that we all live in today. Just think about it. From the heating effect that makes your breakfast, to the magnetic effect that spins the motor in your fan, all the way to the chemical effect that gave your faucet its shine. These aren't just abstract concepts. They are the fundamental building blocks of almost every single piece of modern technology. So, the next time you flick a switch, you'll know it's not just one thing happening. You're unleashing a whole world of potential. And that really just leaves you with one question, doesn't it? Now that you know the secrets behind the current, what could you build?